Hey guys, this side Anirudh. I'll be your trainer today. So we have few sessions that we already gone through for BGP. So welcome to the next session. Let's go on.
Whichever. So how can we solve this problem now? Because R2 is working as edge router. Yes. So do one thing, move back again on R2, and on R2 you can configure this command neighbor 23.1. Once you will configure this command on R2, see on R2 I configured it only for IBCP neighbor R3, not for R1. R2 was receiving this prefix coming from EBCP neighbor and giving it to IBCP neighbor R3. But this time after configuring this command 23.1.3 next hop self, you see that on R3 what will happen? Next hop has been updated. You understand? Next hop has been updated. Now R3 must, because it is best for R3, so it must advertise it towards R4. But will it really advertise towards R4 now? No, due to IBGP rule. Because if you receive anything, any update from one of the IBGP neighbor, then you will never advertise it towards another IBGP neighbor. It means that on R4 you cannot find this. Any problem? So how can we solve this problem now? By using route reflector. So what can we do? We can define this R3 as route reflector server, and we can define this R2 as a client. Even we can also configure this R4 as a client as well. It's not mandatory, but you can, right? As you know that route reflector can exchange routes in between, can reflect routes in between client and non-client, client, but it is not possible for route reflector to exchange to reflect routes to reflect prefixes in between two different non-clients. So move on R3 now, and on R3, as you know very well that we are running AS200, and then you wanted to configure 3.1.2 as a route reflector client, and in same manner you can also configure 34.1.4 as a route reflector client. Fine. So this time you must see this prefix available on R4. But again for R4 it is not best, because might be next hop is not reachable. 23.1.2, is it reachable from R4? See, check its routing table now. So of course if you configure next hop self command on R3, then its effect should be on R4. So move on R3 and then say 34.1.4 next hop self. Once you will configure this command over here, you see there is no effect. Remember, next hop self command can work only on edge router when you are receiving prefixes coming from EBCP neighbor and you are advertising them towards IBCP neighbor. So remember, this next hop self command will work only for edge routers. That's why it was having effect on R2, but this time it is not having an effect. Effect on R3, because R3 is not working as a edge router. So I hope that you people have understood that way to use next hop self keyword. Then apart from this, because still it's not best for R4. So now you have two solutions: either configure a static route or whatever you want to do, but 23's network must be reachable from R4. If this 23's network is reachable from R4, then definitely R4 can define this path, this route as a best path. We have disabled this IBCP rule now. Yes, we are having configuration as well, but right now I'm not going to discuss either route reflector. Even we will also learn these route reflectors on large scale. as well as confederation. So confederation is another way to break this rule of IPGP, apart from route reflector, but we will be discussing them later on. So now you can see that due to next hop issue, this path is not best path for R4, and if it is not best for R4, how will it be possible for R4 to give it to R5? Of course, it cannot advertise this prefix to any other neighbor now, because it is not best for itself. So how can we modify its next hop address? It's possible with using route map. Dinesh, with using route map, here we can modify its next hop address. Try to understand. With using route map, we can modify next hop address, and route map can be applied anywhere. So it's not that route map can be applied. I mean, with using route map, we can modify next hop address only on edge router or on core router. There's nothing like that, because route map can be applied anywhere in the network, and with using route map, you can update next hop address anywhere in the network. Even you can also, I mean, to inject a problem in BGP, you can also configure any unknown address as next hop address. So that BGP will start to create so many problems for you. I mean, Cisco can do it during T-shoot. So this time, first of all, see, for R4 it is incoming update. It's coming from its neighbor R3. Hello. R4 is receiving this prefix coming from, as you can see, show IP BGP 1.1.1.1. You can also see its detailed information. So what is it? This is next hop. See, this is prefix. This is the next hop to reach this prefix, which is not accessible from here, and it is given by this neighbor 34.1.3, and this is the router ID of the neighbor. See, from means this is your neighbor address, IP address, and this is the neighbor's router ID from where we are receiving this prefix actually. So this time R4 was receiving it from 3333. So what is the IP address of 333? 34.1.3, and what is the router ID of R3? It's 33333, highest loopback, is not it? And then that's fine, it is inaccessible. So make it accessible now. Show IP BGP. If I modify its next hop address, and if I configure its next hop address as 34.1.3, if I configure its next hop address as 34.1.3 in place of 23.1.2, will not it work? Of course it must work. It must install that prefix into its own routing table from BGP table, right? So we have to configure its next hop address as 34.1.3, because we know very well that it will be reachable from, it will be accessible from R4. So now point is that in BGP you can update next hop address by using route map. So now I'm gonna do that actually. Like I'll create route map. Route map is name is next underscore hop. Permit by default 10 is there, right? I'm not going to match anything. If I wanted, let's say that I want to change next hop only for this specific prefix only, then definitely I will create one ACL. In that ACL I will call this prefix only, and then finally I'll call that ACL over here under this route map. Are you getting my point or not? But this time, because I don't have that specification, that I just want to change it only for 11111, because if I'm receiving multiple prefixes coming from R3, then also its next hop address for all prefixes must be 34.1.1.3. So I'll be doing it for all prefixes coming from R3. If R4 is receiving any prefix coming from R3, then its next hop address must be configured as 34.1.3. That is why here I'm not going to use match command, because if I do not configure any match command, then by default it will be match all. If you do not match anything inside your route map, by default it is match all. So this is match all, and then you can say simply set IP next hop is what? 34.1.3. So here you have set this next hop address as 34.1.3. Any problem? Tell me. So this is here you have configured this next hop address. Now just come outside, and now router BGP, move back into router BGP to router BGP mode, and inside router mode now you can apply this route map for this particular neighbor. So my neighbor was 34.1.3. route map name is just copy and paste it, And then in which direction? These updates are incoming or outgoing? Incoming updates, because R4 is receiving this prefix coming from R3. R4 is receiving this prefix coming from R3. So for R4, this update will be incoming update. That is why I'm applying this route map for incoming updates only. Of course, we can apply it on R3 as well, but in outbound direction. Right? So I will be doing it in both directions. Don't worry about that. But this time I have applied it on R4. Now you see show IP BGP. So still your changes have not taken place. So in BGP your changes will not take place automatically. So you have to say clear IP BGP star. Now if you say clear IP BGP star, then it will be hard reset, and the meaning of this hard reset is what? That it will break neighborship and reestablish the neighborship, right? So do one thing. Now I'm gonna to capture it. See the link in between R3 and R4, and then I will say I will configure this command on R4 itself actually. Oh sorry. So this is hard reset. In it actually neighborship went down and then reestablished, right? So IP BGP, you see changes have taken place. But in place of this command, you could also use this command as well. Clear IP BGP star in. The meaning by clear IP BGP star in, the meaning by this command is that it will send a route refresh request to all neighbors. It will send route refresh request to all neighbors. So this time it will not break, it will not tear down its neighborship. Means it is not hard reset. It's with using this command actually you are simply sending a message, route refresh message to your neighbors. That's what the meaning by route refresh capability, which is by default enabled in version 4. We saw that route refresh capability and IPv4 unicast address community. These two things were by default enabled in BGP version 4. So after running this command into BGP, what will happen that it will send a route refresh message to its neighbor. So whenever, if you are saying in, it means we are forcing our neighbors to retransmit updates towards me. But for all neighbors, not for a particular neighbor. If you want to do it for a particular neighbor, then do one thing. Say clear IP BGP and then 34.1.3 and then in. This will be for particular neighbor. So the meaning of this command is like I'm asking to this particular neighbor to retransmit my updates, towards me. The meaning by star was, it means you are asking to all neighbors. So even I can show you over here. See, this is route refresh message, right, which is generated by R4. See, generated by 4 towards 3. Simple. And then after it have given an update packet, this 3 to 4. See, 3 to 4. Update will be having path attributes and an array. Under an array, see prefix, under path attributes, all those attributes. Fine. I hope now you have came to know that how to modify next hop address of prefixes with using next hop self as well as route map. Now you do one thing, move back again on R4, router BGP 655, sorry, it is using 200, and then remove this keyword from here and also say no route map, and then say show IP BGP. Still it have not changed its configuration, right? Clear IP BGP star show IP BGP. See, gone. It's not best now. And next hop is again configured as 23.1.2. Now you do one thing, move back again on R3 and create one route map over here. Let's say next and permit 10 match. Don't match anything because we want to configure this next hop for all prefixes which are going in the direction of neighbor R4. So I'll say I will not configure any match command over here. I will simply say set IP next hop, and next hop will be what? 34.1.3. Whenever you will configure set IP next hop 34.1.3, and because this is the local address, right? This is our address, so it will always give you this warning that this is our address. So are you okay? Are you okay? I mean, are you really comfortable to configure your own address as next hop address? So because I know very well that I'll be configuring it for outgoing outgoing direction, for outgoing update, I'll configure this route map for outgoing update. So I know very well that there will not be any problem, but just try to think in perspective of a router. In most of the cases, you will always configure your route maps in inbound direction only, and in inbound direction, if you are configuring next hop as your own address, then definitely it can cause a big problem. That is why it will always give you this warning if you are going to configure your own address as a next hop address. Now just come outside and then do one thing. Router BGP 200 and neighbor is 34.1.4 and route map name is what? Next, in which direction? Out. Now still there will not be any effect on R4, see, but if you say clear IP BGP star in, and if you want to configure this command on R3, then you have to configure this command clear IP BGP star out. This command, this command instructs this router itself to retransmit all outgoing updates. So this R3 will retransmit its updates in the direction of R4, and you see this time again its next hop address has been modified. Tell me, is there any problem in next hop modification in BGP? If you are having any issue in modifying next hop addresses in BGP, please let me know or discuss it with me. Can you configure your own address in outbound? In inbound direction?
इनबाउंड नहीं आउट
आउट में क्या प्रॉब्लम होगी? उसी में तो कॉन्फ़िगर किया है, प्रॉब्लम थोड़ी ना होगी, इसमें तो सॉल्व किया है. Hello, have you people understood this concept or not? Like, you can also configure your route map in outbound direction as well, but make sure that it will be your own address, right? So whenever you will configure your own address as next hop address, then it will always give you that warning message, and you are configuring on address as a next hop address. That's it. Fine. In this way we can perform it. We can do this. Okay. Now this R4 is not going to advertise it towards R5. Even you can move on R5. We can configure BGP. Remote AS will be so IP BGP, it is best for R4. You do one thing, move again back on, nothing, because R4 will receive it from IBGP neighbor, is not going to advertise it towards another IBGP neighbor, because R4 is not working as a route reflector. So in this way, in this case, if you want to solve this problem, you do one thing, move back again on R4 as well. On R4, say router BGP 200 and then say neighbor 34.1.3 is what route reflector. That's it. And this time you have configured this R4 once again as a route reflector, and now this R3 is configured as a client, and this R5 will remain as non-client. But you know very well that route reflector can reflect routes in between client and non-client. That is why this prefix will be available on R5. So remember that a single router can be client for one one router can work as both client as well as route reflector. See, this R4 and R3, both of them are working as client as well as route reflectors. I'll let you know these things in more detail, more and more details during the route reflectors actually. I mean, there is a separate topic of route reflectors. So during route reflectors only I will teach you that, okay, how does it really work and all these things. Fine. So finally now you can move on R5, and on R5 also you can see that, okay, this is coming, but again it is not best because next hop is not reachable, because next hop will be I think 34.1.3, which is not of course it is 34.1.3, which is not reachable from R5. To solve this problem now, what can you do here? Either advertise 34.1.0 in like you can run any IGP over there, any IGP like EICRP or OSPF. You can advertise those prefixes into EICRP or OSPF so that it will be reachable. It will become reachable from all others. Are you getting my point or not? So you can use any IGP over here to solve this problem, or once again configure your route map. I mean, on R5 configure its next hop address as 45.1.4 so that it will become reachable from R5. Fine. So do one thing, once again create one route map. Cisco set IP next hop as 45.1.4, router BGP 200, neighbor 45.1.4. route map name is what? In which direction? Because these prefixes are incoming prefixes for R5. Now see one thing, do clear IP BGP star. Do show IP BGP, check it out. It's best now. Fine. Now do one thing, let's advertise something from R4 into BGP now. Network mask is, so now it will advertise it towards R3 at least. R3 is working as route reflector, it will give it to R2 now. Move on R2, show IP BGP, check it out. It's 444, it's not best. And if it is not best for R2, it means it will not advertise in the direction of R1. Check it out. Is it there? Because in BGP only and only best route information can be propagated towards the neighbors. I mean, BGP can propagate only and only best path information. That's why we are calling it as a distance vector routing protocol as well. So how can we solve this problem now on R2 so that it will become best on R2, and then R2 will start to advertise it in the direction of R1. So how can we solve this problem now? Do one thing, try to advertise this 34's network from R3 into BGP table. Do one thing, move on R3, router BGP is 200, then say network 34.1.0, mask is, so that it will become reachable from R2 now. This 34's prefix, right? Move back again on R2, show IP BGP, check it out. See, now 34 is there, and because 34 is there, it means it will come to know that how to reach this next hop. You understand or not? See, to reach 34's network next hop address is what? 23.1.3, which is directly connected to R2. That is why both of them, 34's network as well as 4444, have become best. And now it will also advertise it. See, till here, to reach 4444, its next hop address was 34.1.4, but whenever R2 will give it to R1, R1 is eBGP neighbor. See, it will advertise it after modifying its next hop address automatically. Check it out. So it has proved that whenever BGP will advertise any prefix towards eBGP neighbor, it will always advertise that information after updating its next hop address. But in case of BGP neighbor, it will never update its next hop information, next hop address. Have you understood it or not? Tell me. So in this way, let me show you that the minimum time interval in between two update packets for EBGP enable is 30 seconds. So you see, interface loop back 1 is what? Shut down. Immediately it will be removed from R2. See, but if it comes up once again, so this time you will see that it will not come here immediately. No, nothing. No, but after all it will come, but after, yes, 30 seconds only. That's why we say that BGP has slow convergence. Now if you go back to R1 and you shut down it, you will see that immediately it will be removed from everywhere. But once again, if it comes up immediately, then again it will take at least 30 seconds. Fine. Apart from it, fine. Again, I'm going to form. First of all, now I'll teach you rule of IBGP synchronization. There is a rule in BGP which is known as IBGP synchronization. So let's discuss that IBGP synchronization rule first now. Right? IBGP synchronization rule. See, nowadays this synchronization rule of BGP, nowadays this IBGP synchronization rule is disabled. By default it is disabled, as you can see here. Like you do one thing, move back again on R5, say show run pipe section router BGP. You will see that there will be a command no synchronization. Remember, this synchronization rule works only for IBGP neighbors, not for EBGP. Or you can say this synchronization rules works only for internal prefixes, not for external prefixes. Things are same, because if you are talking about IBGP neighbors, means you will be receiving internal prefixes from there, and if you are talking about EBGP neighbor, means that you will be receiving external prefixes from your neighbors. Is not it? Fine. So nowadays in BGP, in this BGP version 4, by default this synchronization is disabled, but they can enable it as well. Before enabling it, you must understand that what is the meaning by synchronization rule. See, or what is the meaning by IBGP synchronization, because technically I will be calling it as IBGP synchronization rule. See, according to the rule of IBGP synchronization, if BGP is learning any internal prefix, if BGP is receiving any prefix from its IBGP neighbor, it will never make it best. It will never make it best unless it starts to receive the same prefix via IGP. And here the meaning by IGP is what? ESERP, OSPF or RIP or whatever it is. It means that if you enable synchronization rule in BGP, then within an AS, for IBGP, like for an example, you have configured IBGP, but it will also be mandatory to configure IGPs along with IBGP. It will be mandatory. Like for an example, now I'm on R5 and by default synchronization rule is what? Disabled. See, show IP BGP. Check it out. It is best. All of them are best.
Thank you so much, guys, for watching my video. So we'll be coming back with few more videos of the BGP. Please subscribe my channel. That's @ARC_tutorial. Thank you so much, guys. See you in next video.